So hot gas bypass method. Hot gas bypass to suction side is an effective method of controlling the capacity. When the evaporator pressure falls below a predetermined value, a hot gas bypass valve is opened and hot refrigerant from the discharge side flows back into the suction side of the compressor. A constant pressure expansion valve can be used as a hot gas bypass valve. The disadvantages of this method are little or no reduction in compressor power consumption at reduced load, excessive superheating of suction gas resulting in overheating of compressor. Overheating of compressor can be reduced by sending the hot gas to the evaporator inlet. This also maintains sufficient high refrigerant velocity in the evaporator so that oil return to the compressor can be improved during low cooling loads. And hot gas bypass is normally used for regulating the capacity for small system. So sometimes we have heard that if inside the refrigerant evaporator coil some oil remain in the layer, how do you remove? By supplying the hot gas. This one connection you will see outlet of the compressor is directly supplied to the inlet of evaporator. So that all air, all oil inside the surface of the tube of the evaporator can be removed and coming back to the suction side and crankcase of compressor. It's very important. But this method is not effective because no reduction in compressor power consumption. Superheating of the suction gas resulting compressor overheat. This also maintains sufficient high refrigerant velocity in the evaporator so that oil returns to the compressor can be improved during low cooling loads. However, in conjunction with the other efficient method, hot gas bypass is used when it is required to regulate the capacity down to zero or unloaded starting. So here you will see this compressor, suction lines, discharge line going to condenser. From this discharge outlet of the compressors, one branch line is going from here. This one hot gas line, solenoid valve normally closed. Then it going hot gas bypass valve. It will come to the evaporator outlet, thermostat outlet or evaporator inlet. From evaporator inlet, come to the suction lines. So this one relevant. So this method is used normally for cleaning the evaporator by removing the oil. Or sometimes you can use capacity control to maintain the temperature. So compressors normally condenser receivers, then go thermostatic expansion valve, then evaporator. So it will bypass this method, hot gas bypass valve, evaporator, and suction lines. If you want to put evaporator capacity 0% for unloaded start, then you can use this hot gas bypass valve. So it is efficient in conjunction with other methods. Other method of capacity control you can put together with hot gas bypass, then more efficient this method. Unloading of cylinders in multi-cylinder compressors. Unloading of cylinders in multi-cylinder compressor is another effective method of regulating compressor capacity. This is achieved usually by keeping the suction valve of some of the cylinder open during the compressor stroke. As a result, the suction vapor draws into these cylinders during suction stroke is returned to the suction line during the compression stroke. So this is done with the help of pressure sensing switches, which senses the low pressure in the evaporator and open some of the suction valves. In addition to the capacity regulation, this method is also used during pour down so that a peak power point can be skipped. This method is efficient as the required power input reduces with reduced cooling load, but not in same proportions. Compressor speed control. Controlling the speed of the compressor by controlling the capacity of compressor by regulating its speed is one of the most efficient methods, as required power input reduces almost in the same proportional with the cooling load. So it is more efficient because here same proportion of the cooling load, power also input reduces. However, for complete control, a variable frequency drive may be required, which increases the cost of the system. Here we are using variable frequency drive motor, which will costly, so it will increase the overall system cost. But it's more efficient because cooling load directly proportional to the power. In addition, reducing the speed too much may be affect the compressor cooling and coil return. If speed is too much, then oil return is also less. Compressor cooling also affected.